Good morning. All right. Well, today we're going to look at section 1.6. This is modeling linear equations. Remember that this is for Group A today. Group B, you're going to be in class taking the STAR test, and then we'll flip-flop on Monday so that Group A will take the STAR test and Group B will be working on these notes. Okay, so let's take a look at number one. Jim goes to the fair. It costs $5 for admission and $2.50 per ride. Jim spent a total of $50. What is the variable for this problem? So when looking at these problems, it's best to highlight the information that they're given to you. So $5 for admission, then we have $2.50 per ride, and then a total of $50. Okay, so anytime it says the word total, we know this is going to be an equal sign. We have this word per right here, which is a keyword because that means that that's going to be the variable that's changing, right? Okay, and then we have $5 for admission, which doesn't change. Once you're in, that's it, right? You're not changing how many times you're admitting to the place. What is the variable for this problem in part A? Well, that's the number of rides, okay, which we can probably just say is R or X or whatever variable you want to use. Then it says write an equation. Okay, well, again, as we talked about, it's $2.50 per ride, so per being times. Okay, so this is $2.50 per ride plus the $5 for admission. It's a one-time fee, so there's no variable by it because it doesn't change. And then it's an equation, so there's an equal sign. And lastly, there's a total of $50. Okay, so there is our equation. All right, so how many rides can Jim ride? Well, now we're going to go ahead and solve it because it wants to know, okay, if he spent $50, how many rides did he ride? So $2.50 R plus 5 equals 50. Okay, so I'm going to solve for R. Well, remember what we talked about before. We're going to get rid of this 5 first from each side of the equal sign. This gives us 45. These cancel out, so I have 250 R equals 45. And now I'm going to divide by 250. Okay, so R equals 45 divided by 250 is 18. So 18 rides. Okay, so not bad. All right, number 2. Michelle's score on a science test is 8 more than 3 times Jared's score. 8 more than 3 times Jared's score. What are 2 unknowns in this problem? Well, first of all, we don't know Jared's score. Okay, we'll call that J. And the second thing we don't know is we don't know Michelle's score. So we'll call that M. Then it says, write an equation. Okay, so Michelle's score on a science test is 8 more than being plus, 3 times Jared's score. 3 times Jared's score. Okay, so that tells you right there, okay, that we are trying to solve for M. And again, there's a key word here. Sometimes it's because it's a small word, we don't really think about it, but is means equals. So Michelle's score is 8 more than 3 times Jared's score. Okay, so if Michelle's score is 47, what is Jared's? So we're going to plug in for M, and then we're going to solve. The 8's cancel, and then I'm going to divide by 3 because it's 3 times J, so the opposite of multiplication is division. Okay, and 39 divided by 3 is 13. So Jared's score is a 13. Okay. 3 consecutive numbers have a sum of 72. What are the 3 numbers? 3, and then this is huge right here, consecutive. Think about it. What does the word consecutive mean? Well, consecutive means one after another, right? So you could say that 1, 2, and 3 are consecutive numbers because it goes right after another. Same thing for, 10, 11, 12. Those are consecutive numbers. So how do we get from one to the next one? Well, to go from 1 to 2, we add 1. To go from 1 to 3, we add 2, right? So if we don't know what any of these numbers are, and then get the next one, you would add 3. So if we want 3 consecutive numbers, we can label them as N, and then the second number, like the 2 that we had in this example, right? would be that same number, so n plus 1 gives us a 2. So n plus 1. And then our third number to get there from the original was n plus 2. Okay, so that's how you can represent those. And then once you find, like, we're going to use this to figure out what n equals. And then once you figure out what n equals, you can plug it back in. That'll give you your first number. And then add 1 to that. That'll give you your second number. And then add 2 to that, and it'll give you your third number. Okay. What equation can we now set up that we can write the numbers algebraically? Okay, let's go ahead and set up the equation. So since they are 3 consecutive numbers and they have a sum of 72, okay, that means that all of these are going to be added together to equal that sum of 72. Okay, so now we're just going to copy and paste, and we're going to solve that equation. Okay, so first thing we want to do, we notice it's all addition, so we're going to combine like terms. We have 1n, 2n, 3n's, and we have a couple constants, positive and positive. Okay, so 1, 2, 3 n's, and 1 plus 2 is 3. That gives us 72. So subtract 3 from both sides. That gets us 69 equals 3n. Okay, so 3n equals 69. Divide by 3, divide by 3, n equals 23. So that's our first number. Okay, so n equals 23. So if you think about it consecutively, like we talked about up here, you're going to plug them in. So 23, add 1 gets you 24, and add 2 gets you 25. So 23, 24, 25 are the 3 numbers. Okay, and if you wanted to check your work, you could add them all up, just like we did before, and make sure that they equal 72, which in this case they do. Okay, so you're going to work on these practice problems. There's a couple here, and then get to the exit ticket. In class, we're going to go through them together, but I really want you to give these a shot. I'm going to post a key for these practice problems as well on Canvas so that you can take a look and know exactly how to solve them, and then the exit ticket will actually be graded. So practice problems, there will be a key posted. Exit ticket is at the bottom. This is what you're submitting for a grade. Notice it says the word exit ticket. All right, have a great weekend for those of you that are watching this on Thursday, and if it is Monday, I will see you all in a little bit.